Okay, trying to show you how t- how back how gradient descent works the fastest possible. So basically, you have your AI model. So you run a forward propagation and then a backward propagation. I made a video on this. But for the back propagation, you want to know how to um, do you need to add more or subtract to and by how much your weight to make your model learn. So basically, an AI so an AI is just has just a number of dimensions, and the number of dimensions is the number of weights. So if we just take one weight, we only have one dimension, so we can plot it on a graph. So this is the value of your weight, and this is the loss. The loss is how much better is your model. So if your loss is low, it means your AI is good, and if the loss is high, it means you have a lot of errors. So let's say, for example, if it look like this, the graph looks like this. So basically, we can imagine we start. Um, let's say we start with a value at 0. So your neurons start at the value 0, and you want to know if you need to make the weight bigger. So, for example, you put 1, or you need to make it less. So, for example, -1. So, do you want to go in this direction or this direction? And by how much? To do this, you need to look out to how the curve is behaving. So, as humans, we know it has to go in this way to be for the loss to be less, but the computer doesn't know this. So to do this, we use a math um, tool called gradient. So if we have an x and y, we can know what is the direction of the curve by calculating the gradient. For example, let's say it's like this. So the gradient is the derivative. So like this. So, for example, we know if the curve is like if the derivative is going down, it means that the model is getting better because the loss will go down. So, to make the loss going lower, we need to, if the curve is like this, we need to go to the right, and you need to continue this. So, going down once your gradient is still steep. And once your gradient is flat, it will be equal to 0. 0. It means that you went into the local minima. So it's the lowest point you can get. So basically, your model will calculate the gradients, understand that the gradient is negative, so it needs to go to the right. So now it will be right here. It will try, see that the gradient is also still negative, so go to the right, continue, and once it arrive here, and here the gradient will be equal to 0, so he knows he has to stop here. So this is in theory, because for example, let's say the graph doesn't look like this, but instead look like this, and you start here. So if you don't make your model correctly, it will train. So it will go like this, then here, and here the gradient will be equal to 0. So it will think it has reached the end. But you can go lower. See right here, it's lower. But it will see that here it has to climb up. So it will go on the left and stay in here. Much like a ball. If you put a ball, it will roll like this and go and then stay here. So you need to introduce some momentum so that the ball, if it rolls like this, it will try to go outside. And if it has enough energy, it will find out that later you can go even lower. So yeah, this is just this. Gradient descent is just this. It's just that this is in so gradient is basically derivative, but you can apply this for multiple dimensions. So this is only one dimension, but model is in general multiple dimensions, thousands or billions of them. So that's why we use gradient instead of derivative, because it's just derivative, but for a lot of dimensions. And this is how model works. This is how they train. So when you want to train ChatGPT, it's really this that you are doing. Yeah, I hope you find this video helpful. If you want, I will do a series, so you can watch the next one.